Hello guys, we have a question here. It says a body of mass 25 kg moving at 3 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of sliding friction. Take acceleration due to gravity g equal to 10 meters per second square. So in the usual fashion, we're just going to sort out the parameters for this question. We are told that the mass of the body is 25 kg and the body was moving at an initial velocity u equals to 3 meters per second, and it was brought to rest, which means the final velocity is 0 after covering a distance s equals to 2.5 meters. We are given that the acceleration due to gravity is 10 meters per second square, which will help us determine the weight of the mass, and then we have to calculate the coefficient of sliding friction, mu. Sliding friction means the friction that occurred while the object is slowing down in the process, mu. If we recall, the formula for mu is equals to force all over the normal reaction. Force applied to the object to slow down the object, and the normal reaction is the weight of the object. In physics, force is given as mass times acceleration, ma, while reaction is simply the weight of the object, which is mass times acceleration due to gravity. Looking at this formula, you can see that the mass is the same for both the force and the reaction, so they can cancel out and you will just be left with mu equals to a all over g. So we can evaluate the coefficient of the sliding friction by calculating the ratio between the acceleration and the acceleration due to gravity. So how do we get the acceleration? If we look at this formula, there is no acceleration, sorry, the parameters, there is no acceleration there, but we can get acceleration from the simple equation of motion. So if we recall an equation of motion that takes into account acceleration, u, v, and s, which can be able to calculate a. And that equation of motion is v square equals to u square plus 2as. So this equation of motion covers all the parameters we have here, and we can make a subject of formula. So if we make a subject of formula here, the u square will cross the equal to sign first to become minus u, and the 2s we finally cross to divide on the left hand side, so that v square minus u square divided by 2s equal to a. So now we've made a subject of formula, and we are just going to substitute the values into this equation. So our a is equals to v is 0, so 0 square is also 0, minus u is 3, so we have 3 square, all over 2 times s is 2.5, all over 2 times 2.5. And that will give us a equals to 0 minus 3 square is 9. 0 minus 9 will give us minus 9 all over 2 times 2.5 is 5. Minus 9 all over 5 is equals to minus 1.8 meters per second square. So this is the acceleration with which the body slowed down. The negative sign is only telling you that the speed is reducing as the body is slowing down. So the minus is only an indication that this form of change of speed is a deceleration, it's a reduction in speed. And we are not going to be bothered about it because we are just going to be taking the ratio of 2 acceleration to get mu. So we'll ignore the negative in this instance because we are just after the absolute value of the acceleration. So if we recall our equation, mu equals to a over g, we can come back to this. Mu equals to a over g, and that is equals to a is 1.8. We omitted the negative because we are looking at the absolute value. Like I said before, the negative only tells us that the body is decelerating. All over g, g is 10, and if you do 1.8 divided by 10, that will give us mu equals to 0.18. And this is our final answer. Thank you very much for watching. Hope you enjoyed the video. Bye bye.